Sweet, sticky, and irresistibly delicious, honey is made by one of the most intelligent creatures on the planet, the honeybee. But have you ever paused to wonder how this golden nectar makes its way from flower to jar? Stay with us, because today we're diving into the hive to unravel the mesmerizing journey of honey. Step 1. The bee colony. First things first, let's get acquainted with the members of a bee colony. In each hive, there are primarily 3 types of bees: the queen, the worker bees, and the drones. The queen is the heart of the hive, laying thousands of eggs to sustain the colony. Worker bees, which are female, have various jobs including foraging for nectar, defending the hive, and nursing the young. Drones are the males whose primary role is to mate with a new queen. Step 2. Flower sourcing and nectar collection. Worker bees are responsible for flower sourcing and nectar collection. They can cover up to a 5-mile radius from their hive and visit between 50 and 100 flowers on a single trip. These bees have specialized honey stomachs, designed to store nectar, separate from their digestive stomachs. When a bee lands on a flower, it uses its proboscis, a long straw-like mouthpart, to extract the nectar. This action also helps the flower make seeds, a process known as pollination. Enzymes are added to the nectar during this process, initiating its transformation into honey. Did you know that bees are not just busy workers, but also have a sharp memory? They can even recognize human faces. And what's more, they have the ability to remember the pattern, color, and scent of various flowers. Clearly, these little creatures are some of the most intelligent beings we share our planet with. Step 3. Returning to the hive. After collecting nectar, worker bees make their way back to the hive, their honey stomachs filled with enzyme-altered nectar. The hive is generally within a short range, allowing bees to quickly return and unload their precious cargo. Once inside the hive, the worker bee transfers the nectar to a house bee. This transfer isn't just a handoff. Enzymes from the house bee's saliva further break down the nectar's complex sugars. The house bee then deposits the enzyme-rich nectar into a honeycomb cell, but the transformation isn't complete yet. Step 4. Transformation. The process of turning nectar into honey is a communal effort inside the hive. After the house bee deposits the nectar into a honeycomb cell, a crucial phase called evaporation begins. The high water content of the nectar must be reduced for long-term storage. Worker bees take on the role of live fans, vigorously flapping their wings over the open honeycomb cells. This action accelerates the evaporation of water from the nectar, concentrating it into a thicker substance. Once the nectar's water content drops to around 17–18%, it's time for the final transformation step, sealing the honey. Bees produce beeswax from special glands on their abdomen. They use this beeswax to cap the filled honeycomb cells, creating an airtight seal. This wax cap not only keeps the honey fresh, but also signifies that it's ready for consumption or storage. From this point on, the nectar has officially become honey, a remarkable result of teamwork, biological precision, and natural chemistry. Another fun fact. Did you know that it takes the lifetime work of approximately 12 bees to make just 1 teaspoon of honey? That's right. Each tiny bee works tirelessly to contribute a minuscule amount to what eventually becomes that golden jar in your pantry. Did this fun fact sweeten your day? Hit that subscribe button for more videos like these. Step 5. Storage. After the nectar turns into honey, house bees carefully place it into the hive's honeycomb, a beeswax structure with hexagonal cells. These cells serve as efficient storage units that maximize space within the hive, crucial for sustaining the bee colony during resource-scarce periods like winter. Once each cell is filled with honey, bees use a softer form of beeswax to create a tight seal, or cap, on the cell. This capping process serves a dual purpose. It locks in the honey's freshness and shields it from external contaminants. The airtight seal is vital for preserving the honey's quality and extending its shelf life, ensuring it remains a reliable food source for the hive or for future human harvest. Step 6. Beekeeping. After the bees have done their part in storing and capping the honey, beekeepers step in to manage the hives. They monitor hive health, looking for signs of diseases or pests like varroa mites, and apply treatments as needed. Proper hive management, including clean and well-maintained frames and boxes, helps ensure a successful harvest. The beekeeper's role isn't just maintenance, it's also about knowing the right time to harvest honey. Once they observe a significant amount of capped honeycomb, beekeepers recognize it's time to collect. Harvesting typically occurs from late spring to early fall, depending on local flowering cycles and climate conditions. Accurate timing is vital to ensure high-quality honey and to keep the bee colony thriving. Step 7. Harvesting to harvest. Beekeepers wear protective gear and often use a smoker, a device that releases cool smoke, to calm the bees and make them less aggressive. This is crucial for the safe removal of honey frames from the hive. Specialized tools like hive tools and frame grips are employed to carefully lift out the frames that are filled with capped honey. The frame, bustling with bees, is gently shaken or brushed to remove the bees and return them to their hive. Great care is taken not to harm the bees during this process. Once safely removed, these frames are set aside for the next step. Step 8. Extraction. Once the frames filled with capped honey are collected from the hives, they are taken to a specialized honey extraction facility. Here, the first step is uncapping, where the wax seals are carefully removed from the honeycomb cells, usually using a heated knife or a specialized uncapping machine. Next comes the extraction phase, where the uncapped frames are placed into a honey extractor, a large centrifugal machine. When the extractor spins, the honey is forced out of the honeycomb cells and collected at the bottom of the machine. Step 9. Filtration and pasteurization. After the initial extraction, the honey still contains impurities like beeswax particles, propolis, and other minute hive debris. The next stage is filtration, where the honey is passed through a series of fine mesh filters to remove these impurities. The goal is to achieve clear honey while retaining its essential nutrients and enzymes. Some commercial honey operations also opt for pasteurization, a heat treatment process to kill any existing bacteria and extend shelf life. While this does ensure a longer-lasting product, it can compromise some of the honey's natural properties, like enzymes and flavors that are sensitive to heat. Step 10. Packaging. After the honey has undergone all the necessary purification and treatment processes, it's time for bottling and packaging. In modern commercial settings, this is typically an automated process. Machines fill pre-sanitized jars or other containers with the filtered and possibly pasteurized honey, ensuring precise measurements and minimizing waste. Once filled, these containers move along the production line to be sealed. Airtight seals are crucial for maintaining the honey's quality and prolonging its shelf life. After sealing, labels containing nutritional information, sourcing details, and brand identification are applied to the containers. The final step before these honey jars hit the market is quality assurance. Each batch undergoes rigorous testing to confirm its texture, flavor, and overall quality meet the established standards. Only after passing these tests does the honey make its way to the distribution phase, ready to sweeten the lives of consumers.